Hello there, Year 9's Mr. Herman here, and this is exercise 3F, negative indices. The learning goals for this one is to understand how a negative power relates to division, and to know how to rewrite expressions involving negative indices with positive indices. The success criteria for this one is to be able to apply index laws to expressions involving negative indices. Now, negative indices, consider it the seventh rule or seventh law. While the key ideas and what rules apply to it seem relatively simple, you are going to get into questions that go into some pretty intense algebraic territory. So count that as a bit of a warning, just in case you get intimidated by a lot of letters. But just remember that there are these laws and rules to help us out, and at the end of the day, all we're doing is rewriting one expression in a simplified version. That is it. Apply the steps and you'll be fine. So the first key idea that we have here is any base number to the power of a negative indice, so minus m in this case, can be rewritten and should be rewritten as 1 over that same base to the power of m without the negative. So these two are implying the same thing. Now, this rule does not make sense. In one of the second examples, I'll show you why this is the case. You will approach negative indices. So in this example here, this is saying 2 to the power of negative 3. This is just saying 1 over 2 to the power of 3, which is 1 over 8, as 2 to the power of 3 is 8. So this here, 2 to the power of negative 3, implies 1 over 8. In general, if you have a base number to the power of a negative over here, a lot of students assume that your answer should be negative as well because the power is negative. That isn't the case. It's implying that the number is going to be less than 1. In this case it is, because it's always going to be 1 over whatever that base is to a positive power. Now, just bear in mind that that's assuming that there are no other numbers associated with the 2, like there's an x with it, or y, or even a 4 times with it as well. Okay, so just be careful with that. Now, the second key idea, 1 over a to the power of negative m. So if the base is on the bottom and it also has a negative associated with this, this is also the same as writing it as a to the power of m. Okay. So in this instance here, 1 over 2 to the power of negative 3 is the same as 2 to the power of 3, which is 8. So there's kind of this reverse rule that's going on between these two key ideas. Let's look at some examples to apply this with the other index laws in motion. Okay, express each of the following using positive indices. The first case, this is b to the power of negative 4. So remember, when the power is negative, this becomes 1 over whatever that base is, b to the positive power. So 1 over b to the power of 4. Fairly simple in this case. Second one, 3x to the power of negative 4 y squared. What we can indicate is there's only one term that has a negative power, so that's the term that goes into the bottom. Any terms that don't have a negative power, so in this case 3 and y squared, will stay on the top. So it will be 3y squared that stays on the top, and the only thing that goes onto the bottom is x to the power of 4. Please just be mindful, I've seen some students put x to the power of negative 4 on the bottom. Remember, once it goes into the bottom or the denominator, that negative disappears and the power still remains the same, but the negative disappears. And this is what I was saying before, when you have other things associated with this negative power with the x base, they just stay on the top. So the 3 and the y squared just stay on the top. 5 for C, 5 over x to the power of negative 3. Now we have a base to the power of a negative number, which is on the bottom, so it goes back into the top, and that negative power, or the negative to the power, disappears. And remember that 5 still stays on the top, so it tags along with it. 5x cubed. The second set of examples, again, we're going to simplify the following expressions, but this time we've got a bit more going on. First one, we have 2a cubed b squared all over a to the power of 5b cubed. Now again, all you got to do is associate the letters with each other. Because we're dealing with a fraction or a division, we are subtracting the powers. So this is from the skills that we should have practiced from the previous exercise. So in other words, this will be 2a 3 take away 5 is 3 take away 5, as division is a takeaway for the powers, and b 2 take away 3. So we end up having 2a to the power of -2 and b to the power of -1. Now in this case, both of these powers are negatives, so it ends up being 2 all over a squared and b to the power of 1, but we can just leave as b. So 2 all over a squared b. Now I was going to show you why this is the case, where these negative powers imply that they do go into the bottom. So if I were to rewrite this, and I am going to wipe this off because I need room for this question here, but if I were to write this out expanded, it's going to take a while, so I'll just pause and have it all expanded. Alright, this is a question here expanded out. 2 times a times a, because it's power of 3, and b times b, and again 5 lots of ab multiplied with each other and 3 lots of b. And the rule was, for every a that you see on the top that is on the bottom, it gets cancelled out. Well, technically turns into ones. So this gets cancelled out with this gets cancelled out with this. There is no more that can be cancelled out because we've run out with all the a's. Same thing with b, we've got a b here, and we have a b here, b here. So what we're left with is 2, because every single one of these have turned into ones. So 2 times 1 times 1 times 1, etc. just ends up being 2. And what we're left with the bottom is 2 lots of a's and a b. Voila, this is exactly the same as what we have here. So this is why when we have a negative power, it ends up going to the bottom, because when we simplify this anyways, this is what ends up happening. Okay. So now that we have this in mind, I'm not going to show you the expanded. Again, we're just going to apply the negative index law rule to solve this next question, and I'll put a bit of space for this one. So 4n to the power of -2n cubed all over 8m to the power of 5n to the power of -4. All right, let's see what's going on here. The 4 and the 8, or the 4 over 8, I already know that this is going to simplify down to a half. Okay, so 4 over 8 is the same as a half. So that knocks out one portion of it. So the second part, we have m to the power of -2 take away this power here, 5. So we have m to the power of -2 take away 5. Maybe it's a division, so we're going to take it away. And then we have this n to the power of 3 taken away and -4. Now two negatives will turn into a positive. So this is just n to the power of 3 plus 4. And remember, this half, we've already done the simplification, so this is technically going to be all over 2. Or you can write it with the half in the front just for now, if it makes it easy, because we know that we've got this half, okay, that's tagging at the front, and then this we can simplify further down. So half m to the power of -2 take away 5 is m to the power of -7, and n will end up being positive 7. 3 plus 4 is 7. So what of these terms are going to go into the bottom? Well, just the m. So this will be, what stays on top is a 1. We don't need to write 1, but mainly the n to the power of 7 stays on the top. What goes put onto the bottom is the 2, because that's part of the denominator, and m to the power of 7. Now, again, you can also write this as half n, sorry, to the power 7 over m7. This is quite a weird way or abstract way to write it. Some of the older textbooks might have it in this format, but this is implying that it's going to be this times this anyways. So this format here is a better approach. The only time that you can have a half in the front, if there's a term next to it that's generally not in fraction form. So it's an n to the power 7 and that was it. But in this case, this is the format that I want to see. Alright, the next set of examples that we're going to look at now, this isn't a walk in the park. There's going to be a lot of steps involved. In fact, the first question itself has 1, 2, 3, 4, 5 lines, with the answer being the last line. So 6 lines actually, 6 lines. So there's quite a bit that we need to dissect from this question here in order to simplify it. This will show you how your skills with all the index laws come into play, and we want to make sure that we get every single skill absolutely correct, because it is so easy to make a mistake with a question like this. Now, please don't feel intimidated by this type of question. All we're doing is applying rules to simplify, and if you have that at the back of your head, it should give you some form of hope in order to answer these questions, or these type of questions. Okay, the first thing that we can see within this expression is that it's been split up into 2 parts and there's a times in the middle. I'm just going to focus on this here separately with this here, because I can see that there are brackets involved and I want to expand accordingly. So what we're going to put down is this here, when there is a power to the 4 that's associated with terms inside the bracket, that 4 gets associated by both the p and the q, and we've just got to remember that this is p to the power of -2, so this is going to be multiplied with that power 4 here, the q, the p to the power 4 as well. The bottom fraction, we'll leave it unchanged for now. Obviously it will be simplified afterwards, but we kind of had to expand that first bracket first, or the numerator bracket first, before we can simplify this whole fraction if need be. The second expression here, we have a -3 that's associated with both the numerator and the denominator, so we're just going to multiply that -3 by both of those powers there. So this becomes p to the power of -2 times -3 all over q times 3 to the power of -3. So all I've done was this, I've done my expansion with the powers outside of the brackets, whether it's just on the numerator or both the numerator and the denominator, and now I'm just going to simplify any multiplications within the powers that I see. So this will be p to the power of -8, q to the power 4 stays untouched, and everything on the denominator also stays untouched. Okay, so I've just simply multiplied those two. This p will turn into p to the power of 6, because -2 multiplied by -3 is a +6. And this q, should I make q more of a tail, I don't want it to look like a 9. This q is to the power of -9, as 3 times -3 is equal to 9. Okay, we're getting there. We are getting there. So what I can see here is I've got this multiplication between these two fractions, and I also can see this 5 on the bottom. And now what I'm going to do, for reasons that will make this easier, is this is technically 1 over 5. The 1 is just invisible. So I'm just going to separate this 1 over 5 here just for the time being, because this is a number component to whatever this is. Okay, so let's just separate this for now. Let's keep it aside, and let's use index law rules for multiplication and division to see if we have to add or take away relative powers. By relative, I mean relative, the p is relative to the p, q with the q. Let's first look at the p. This p to the power of -8 is going to have this -1 being taken away from it. Because remember, there is a division, so it's take away. and there's a -1 associated with this power. So it's -8, take away -1. And then we're also going to add a power of 6, as this is being multiplied with this power here. And just to play it safe, when I see two negatives put together, it turns into a positive. So that's the P's all sorted out, and then we can simplify in the next line. The Q is going to have 4, take away 3. Okay, so we've got 4, take away 3. And we also have another division, because it's a fraction, it's on the bottom of the fraction, so we're going to take away a -9. If it was on the top, it would be added. Because it's on the bottom, we are going to take this away. And again, to play it safe, anytime I see two negatives put together, I turn it into a positive. So this here is implying that we have the 1/5 at the front. We have P to the power of -8 plus 1 plus 6. So that would be -8 plus 7, which is -1. P to the power of -1. The Q is 4, take away 3, which is 1, plus the 9, which is 10. So this is Q's power -10. So this whole expression here has simplified to this. Got to remember, when it comes to negative index laws, that P to the power of -1 has to go into the bottom. So this becomes 1, because 1 is on the top. We don't really like the 1. I've just put the 1/5 at the front just to separate it so it doesn't get too confusing. What stays on the top is Q to the power 10, and what goes into the bottom is the 5, because that's on the denominator here, and P to the power of 1, which I will just leave as P. And this here is our final solution. Now, I want you to realize that there could have been, at any point, I could have made a silly numerical mistake when it comes to my powers. Okay, I could have forgotten whether to add or subtract. It's so easy to get these rules quite mixed up. Okay, so really pay attention to how you're approaching this and what steps you're applying in order to get your solution. Alright, let us tackle B. I've just had to make A a little bit smaller so I can leave a bit of room, because this one here is going to have quite a few lines as well. And we're also going to implement a keep change flip, because we can see that there is a division. When I scroll up, there is a division. There we go. There's a division involved. So we want to apply a keep change flip from our fraction rules. Okay. How do we tackle this one? Again, we've got some brackets with powers involved, so we know that we have to expand everything within here. So every single expression or term that's within this bracket has a power of 3 associated with it. Same thing with this expression here, but instead of 3, it's a power of 2 associated with it. So let's put the associations first. So this is going to equal 2 to the power of 3. Okay, so 2 to the power of 3. M to the power of 3 multiplied by 3. This is all over R to the power of 2 multiplied by 3, and N to the power of -4 multiplied by 3. Okay, so we just associated that the 3 with everything there, the numerator and the denominator. We're then going to do it with these terms here. This is going to be 5 squared. This is going to be M to the power of -2 times 2. This is going to be N to the power of positive 3 times 2, all over R to the power of 2. So we've done all of our expansion first. Let's do a little bit of tidying up. 2 to the power of 3 is 8. So 2 times 2 times 2 is 8. This is going to be M to the power of 9, all over R to the power of 6, N to the power of -12. That's -4 times 3 is 12. Now, I've already made a little bit of a boo-boo just out of habit. Gotta remember that this is a division. This is a division, not a multiplication. It will turn into a multiplication soon enough. For now, let's keep it as a division, because the question implies it's division. 5 squared is 25. This is M to the power of -4, N to the power of 6, all over R to the power of 2. Okay. Now this is where our keep change flip is implemented. I keep change flip. Because we have a division here, it's hard to apply these index laws when there's a division between two fractions. So what I'm going to do to make this easier to read or easier to tackle, I'm going to keep my first fraction with all the relative terms involved. 6 and 12. I'm going to change the division into a times, and I'm going to flip the second fraction so it becomes r squared over 25 m to the power of negative 4 n to the power 6. Okay, we've got to this part here. Now, there is an 8 on the numerator multiplied by a 25 on the denominator. For the sake of simplicity, let's just take this out and deal with this later. Okay, let's just take out the 8 and 25. Right now, we have an m to the power of 9 minus a negative 4. So it's minus because we're dealing with a division, and it's negative 4 because the power is negative 4 in this case. Two negatives create a positive. We also have an r. This is 2 take away 6, as there's a 2 on top, and it's being divided by a power 6. Now, we're in a situation where there's no other terms on the top, and the other term we have is an n. Okay, but there's no n on the tops, so I can't just simply write n, whatever the term is, and then do my division and subtraction. So what I'm going to do is keep the n's on the bottom just for now, because there are no n's on the top to start off my power addition or subtraction. This is n to the power of negative 12, and you've got to be careful now, because we're in the bottom territory, we're with the denominators. These denominators are being multiplied with each other because they're staying on the bottom. And when they're being multiplied with each other, it's an addition. So it's negative 12, and in this case, it is plus 6. Okay, so be very, very careful of this step. Okay, it's not a takeaway. They're both on the bottom, so all these bottom terms are being multiplied. All right, let's do a little bit of algebraic tidy up. This is 8 over 25 multiplied by m to the power of 13, r to the power of negative 4, all over n to the power of negative 6. And now we can do our little tidy up. Let's put our 8 back on top. What stays on the top is the m to the power of 13. What now goes to the top is this n to the power of negative 6. When it goes to the top, it turns into n to the power 6. What stays at the bottom is 25. And what goes to the bottom is the r to the power 4. And this, my dear friends, is the solution to a very complicated simplification question. So 8m, 13, and 6 over 25 r to the power 4. Good work for staying with me for this long. I know it's not a walk in the park, and I know you're going to struggle with this one. So remember, there are 2 periods for us to tackle these set questions. Have a look at the log sheet to see which questions you need to do for exercise 3H. I just totally forgot. I think it's 3G, 3H. Pretty sure it's 3H. If it's not, then excuse me, pardon me. I'll have to go check. Hold on. I was incorrect. I was getting confused with my year 8s because they're working on the chapter 3 as well. It is exercise 3F, negative indices. Alright guys, hopefully this is the last video that you have to watch and we're not in remote teaching and learning after this. Until then, at any point, if you wish to skip the certain parts within the video, I'll pause. You're more than free to do so. Hopefully I don't catch you in another video. See you guys.